I'm getting ready to put together all the equipment for the 200 amp main breaker panel upgrade tomorrow. Surge protection device I'll be putting in. This is good for a threshold of up to 80,000 amps. So that's a lot of amperage protection for your surge. PB30 for the connection to the generator. A cord, so you can pick up a pre-made cord from Amazon for less than you can actually make it as the electrician. So unless it's a custom order or a custom length, I just buy it from Amazon now. And then in here, I got a bunch of connectors we'll be using and about $600 worth of circuit breakers from QO. As you can see here, this is the interlock that I'll be putting in. It is model number QOCG-K2C. Of course, all of that will be down in the description. There's all the parts that come with it. I was going to do this last night, but it looks like I'll be doing it on site tomorrow. And I also have the cutout for the main breaker up top. The panel that we'll be putting in tomorrow is going to feed from the bottom. Okay, so here is the 54 space QO circuit breaker. Model number for this one is QO154M200P. Of course, I'm going to leave that in the description in case you want to put this particular panel inside your house or use it on one of your jobs. It comes with these protective covers that go over the terminals for our main service entrance conductors. One here and one there. The thing I like about the Square D is they leave this little probing hole right here so you can put your testers in there to check for proper voltage. I know sometimes I forget to put these on before I energize the circuit, before I energize the service. So I'm usually don't need to use these holes, but the idea is to put these on before you energize the panel, so you're not subject to getting shocked by these two terminals. These are the main service entrance conductors right here. Here's our neutral, and of course the grounding electrode can be connected here on this particular terminal. And then of course I've already installed my main bonding jumper, and what this green screw does is it bonds the neutral on these. The neutral from the main lug right here, from the service neutral, is connected to these terminals on this side and on this side. When you put this green grounding screw in, or a bonding screw I should say, what it does is it engages the screw holes in the back here. And what that does is it bonds the neutral to the enclosure, forming everything inside here to be bonded with the system neutral. And for clearing faults, the green wires and the bare wires are your equipment grounded conductors that come back to this terminal and then eventually back to the grounded conductor, which eventually goes back to the source, comes back on whichever leg is having the problem, and opens up and facilitates circuit breaker to clear a fault. So that's why we put the main bonding jumper in the main disconnect of the house, only in this panel. Everything downstream from this 200 amp main breaker main disconnect panel, the grounds and neutrals are always isolated, so we don't have objectionable current flow on our grounded parts, and we can facilitate a ground fault situation more rapidly and clear the circuit breaker so nobody gets hurt. I don't use sawhorses every day, but at home I have these Bora speed horses, and I really like using them. All right, so a couple other things I bought for this particular job are a couple of emergency lights. So this emergency light will go right above where the electrical panel is. So when the power goes out, these lights will turn on. And then this light will be over by the door entering the room, so you'll have some light to guide you to where the electrical panel is. The ground bus is here by QO and home line with Square D. It's good for a QO or a home line panel. Got all my 30 amp circuit breakers here, which I need, and we're all packed up and ready to go for tomorrow. And I gotta go. Hey guys, welcome back to the channel. Today I'm changing out this old Square D QO panel. It's got 30 circuits in it. I'm sorry, it's got 30 spaces in it, but there's way more than 30 circuits. It's not rated for twin breakers. So today we're going to be changing this out. We're going to be adding surge protection, and we're also going to be doing a portable generator hookup with the Interlock. So welcome back to the channel, and let's get started. We always want to shed the load first, and so this panel on the side here, obviously they relocated a bunch of those circuits to connect to the portable generator, which is what you see on the side. By the way, what is regular power versus emergency power? That's how you can tell for sure that an amateur put this together. Wait till you see the wiring. All orange conductors and nothing identified as a neutral or a ground. Obviously, this is all bootleg right here. This section of the code shows you what color the conductors need to be: grounded, equipment grounded conductors, and ungrounded conductors. Hit pause if you'd like to read more on this section. And I believe this goes out to the old generator hookup on the outside that goes underground. We're going to be disconnecting all that. So I normally wouldn't do this, but what I'm doing here is obviously taking out all of these circuits to go inside the new main breaker panel. But I'm going to isolate the boiler circuit, and I'm going to temporarily connect it to an extension cord just so that we can have heat, because it's 10 degrees outside on this day that we're doing the work. This portion of the audio did not come out well from my GoPro camera. I don't know, I've been having some problems. But what I'm doing here is I'm going to turn off the disconnect switch for the boiler so that when I connect it to the extension cord, there'll be no load and there'll be no arcing, and it'll be the safest way to do this connection. Obviously, if you don't feel safe doing this, then don't do it. Obviously, this is not something I would do permanently. Obviously, this is just to get some temporary heat while I'm working inside the house so I don't freeze. Like I said, it's about 10 degrees, and we're up in the mountains here. And my customer asked me if I could do this for him. One thing you should always do when you're taking circuits out of a panel, if you have a double pole circuit breaker, what I always do is just put both of the conductors together and just tape them together. When I put this back inside the new panel, I'll know that this is a double pole circuit. What is a double pole circuit? A double pole circuit is a circuit that has two poles. And in a single phase electrical service, you're going to have two poles, L1 and L2. That's what double pole is. Okay, see, there's another violation. You got a multi-wire branch circuit on the same leg, which is only going to double the current on the return path on the neutral. But just know, when you have a multi-wire branch circuit, that the black leg and the red leg need to be on different poles, L1 and L2. If they're both on L1, then this is going to carry the current from both of these circuits. Okay, and if this is a 20 amp circuit, you can load it to 18 amps or 19 amps. That means you're going to have 19 amps on your neutral. But if this other circuit also has 15 amps, that means you're going to have 39 amps on your neutral, and number 12 is way too small for 39 amps. Actually, what I meant to say is that if you have 19 amps on one leg and 15 amps on another leg, that neutral current is going to add up to be 34 amps on the neutral. And for a number 12, it's much too small, and you will have issues. To alleviate this issue, we put one of the ungrounded legs to L1 and the other ungrounded legs to L2, and now the neutral will carry the difference between both of the legs. So if you have 19 on one and 15 on the other, the neutral will carry 4 amps. By the way, could you hear the boiler stop after it was satisfied by the thermostat? That's what that noise was. The other thing we must do with a multi-wire branch circuit is use a common trip double pole circuit breaker so that we could disconnect all ungrounded legs while we work on the circuit, because the neutral would have current if only one of them was on. Obviously, when you're pulling these out, you're just trying to straighten them out so they come out easily without damaging the insulation on the conductors. The last thing you want to do is damage the insulation. And you have to make a repair or a splice that's not necessary, that actually slows down the progress of the job. So be careful not to nick the insulation on any of the conductors during a service upgrade. Whenever I see bootleg wiring like this, it really pisses me off. I have my license. It took a long time to get my license, and I do work legitimately. And for some guy to come along and install this system for this lady and take advantage of this customer, saying that, yes, I can hook up your portable generator, and then he does something like this, very dangerous. And that would not be on the person who installed it. If this house were to catch fire, it'd be on the person who owned the house at the time. Just know that about the licensing laws. I really don't do too much with QO because it is rather expensive, but I got to say, after taking out this panel today, and I'm just digesting this video for the first time while I edit it for YouTube, one thing I did notice is that this panel was in there since 1985 when the house was built, and I didn't see any damage to any of the circuit breakers or lugs. There was nothing wrong. The only wrong thing we have here is all this bootleg wiring for that emergency transfer switch there, the manual transfer switch. It was, I'm not sure how the hell they had that working, but they had two double pole 60 amp circuit breakers inside this main breaker rigged up. And so what we're going to do is we're going to put all these circuits into a new panel and add the interlock by QO for the portable generator setup. So truth be told, anytime I do a panel upgrade or a service upgrade that doesn't consist of armored cable or BX cable or any of the old Romex with the wax around the conductors, that stuff takes a lot of time to get these circuits ready. This panel had a lot of circuits, but all of this was like new wiring, most of it from the 80s and some of it from, maybe 15 or 20 years ago. This is a strap inside the main breaker enclosure, all right, holding down the service entrance conductors. I don't know, that to me isn't safe, because this metal could bite into this, and now you're connected. You got the screw right to the enclosure here. That's a major short circuit waiting to happen, or ground fault waiting to happen. I don't know why they would do that, but I gotta go upstairs and pull the meter, and then the service entrance conductors will be dead, and this whole panel, whole house would be isolated from the service. So let's go outside and pull that meter. Yes, I understand that in some parts of the country, in different licensing laws in different states, you're not allowed to open up the meter or do anything with it. As long as I have a permit and I have a valid electrical license, I'm authorized to work on overhead services for this particular utility company, which is JCP&L. The voltage testers that I'm using are made by Fluke. They're called Field Sense, and what that does is it provides an artificial grounding conductor for voltage connections without actually removing any of the terminations, such as wire nuts, to verify for voltage. You can actually read right through the conductors whether or not that conductor has voltage or not, which is really nice. Sometimes I forget I even have them, but I really do like using them when I remember to use that Field Sense feature. So from here on out, we're just going to be removing all of these branch circuits. And the branch circuits are what originate in the panel enclosure here. They get attached to what we call in the trade an overcurrent protective device. In this case here, they're circuit breakers. The Square D QO circuit breakers that we're putting in are some of the best in the industry. The Square D circuit breaker has two magnetic fields, which causes the circuit breaker to trip quickly and effectively. I'm wondering about these connectors right here. All right, well, first of all, this house was built in 1985. And these are the connectors I used to use when I first started wiring condominiums and townhouses back in the early 1990s. All right, I joined the Navy in 1990. And I came back on a reserve duty and became an electrician. These were all the rage. I think they're made by Arlington, and the way you would put these together is obviously they snap in to the KOs right here for the knockout, and they snap in just by this little pressure piece right here. So once you push it down into the knockout, this piece of plastic kind of clips it in place. They were good for the time, and then what you would do is you take your channel locks, your side, I don't know what kind of pliers they're actually called, the channel locks where you have the two jaws that tighten down, but you would take your channel locks like this, like my fingers are going to do, and just clamp down on this clamp, and this clamp keeps the wire in place. So I haven't seen these in a while, but I remember using these all the time. I think somebody, maybe Arlington might have done an update and did white and black ones later on. But they were blue when I first started, and this house was built in 1985, so that explains why they used them here. It was just to speed things up, like everything else in the residential market. What I'm gonna have to do next though is I'm gonna have to take this conduit, this lock nut out of here, and I'm gonna have to cut back this piece of conduit. And I think what I'll do is I'll drop this into a box and then extend it. It's got a 240 volt circuit, 20 amp, and 120 volt circuit, which I think is for the lights in the backyard out by the koi pond. I did some wiring for a koi pond here last summer, but the video didn't come out good, so I didn't release it. This is a little bit more from the koi pond. This is just like a power station and a transformer for the low voltage lights that are actually inside the pond. We had to bury the conduit with concrete because we couldn't get the proper depth, even with the GFCI protection. And here's a bird's eye view of the koi pond. It's really, really nice setup in this guy's backyard. Really, really nice. Go ahead and hit that like button if you're enjoying this content. And if you're so inclined to subscribe, I really appreciate it. I also want to do a little shout out to a fella on YouTube called Nick Johnson. He does a YouTube channel, and it's a pretty big channel. And I ran into Nick when I was at the inauguration with my wife. It was a little anticlimactic because they moved everything indoors, so we gathered at the National Mall to celebrate, and there was only maybe like 1,000 of us. But anyway, Nick was there, and I'm a part of his video. So if you want to go over to Nick Johnson, to his channel, I'll leave a link down in the description below, so you can go check that out. And the other person I want to thank is ALB Electric. I hope I'm saying that correctly. He mentioned a shout out to some of the 5 most influential electrician YouTubers, that pages that you should look at. I'm trying to ABD Electric, ALB Electric. Anyway, I'm sorry I got your name mixed up, but I'm gonna leave a link for that, for his page, in the description below also. My wife and I are very excited that Donald Trump was reelected. We went to the first inauguration in 2017, and it was filled with people. And when we went this time, once he moved it indoors, there wasn't that many people there, but there were a lot of people in Washington, D.C., and I can tell you for sure, because our hotel was very expensive and we stayed outside of the city limits in Largo, Maryland. Okay, so I'm going to disconnect all these old conduits that are just put in like crap, and we're going to rewire this section. As it turns out, I get the panel back up, but there's a couple circuits to go to the backyard that I need to go back and reconnect just for a couple lights. The koi pond's working, so there's none of the fishes freezing in there. And there's bubblers actually in the koi pond, so don't worry about that. So once we get the lock nut and bushing off for the service entrance conductors, we pull the old panel off, and that's kind of like a milestone of sorts when you're doing this kind of work, sort of the halfway point, if you will. And now I'm ready to get my panel into place. And the one thing I didn't account for was how tall this panel was compared to the last one. And as you're going to see here in a minute, I'm going to reuse, obviously, where the service entrance comes in. I can't do anything about that. It actually goes underneath the garage on the outside and comes in. So not exactly the closest point of entrance, if you ask me, as far as the code goes. But this panel was awfully large, so I decided to take out all of the knockouts at the top so I wouldn't have to do that once it's in place. Then I take the knockout out for the service entrance conductors and get that situated, screw it to the wall. Then I'm going to tighten up my lock nut and put on the bushing, and we're off and running to reattach all of the branch circuits. And this is what we do for the rest of the day now. Then at the end of the day, normally we identify the circuit breakers if we have time. We didn't. I'm going to have to go back there later this week to do that. Always don't forget to put the insulating bushing on here. This is important so you don't damage the insulation on the conductors. If you put it on last after pulling the conductors, you've defeated the purpose. Please remember to put your bushings on before you pull the conductors. Okay, so now we're all set, and I got a lot of wires here. Fortunately, most of them are long enough, but one of the issues I do have is I need to put in a couple of ground buses on either side of the panel here for some of the neutrals and equipment grounds that won't reach the terminals that come with the panel, because the main circuit breaker is at the bottom, and that's where those terminals are at. So we're going to wind up putting in a couple of terminal bars and do some number 4 copper jumpers between the new bars and the equipment bus for the terminals down below. Obviously, there's a lot of circuits here, and so you want to put them in one at a time. Try to make them look as neat as possible, so you can work with them. Also, love that lighted Klein torpedo level too. Well, hey, so now they do make these slide-on white connectors in 3/4 size. So that was a revelation. I think somebody on the channel actually told me about that. And these just slide on the wire and clip into the knockout. There you go. That one's in. That's nice. What I have learned from installing these connectors is to slide them onto the cable and then push the cable into position with the connector. And then once the connector connects to the enclosure, now pull the wires back down to where you want them to land. We're going to eventually come back here, obviously now with the utility knife, and we're going to pull away all the sheathing. And this will go on for as long as I have to do this. The other piece of advice I would do is have a garbage can nearby here when you're taking all this stuff down. Or you could put down a drop cloth, and with the drop cloth, you can put all the debris on there and then just wrap up that drop cloth and put it into a garbage can. Or you could do it the old-fashioned way and just use a broom when you're done to clean everything up. Whatever works for you. I'm just explaining what works for me and what makes the job go as easy and as quickly as possible without any jeopardization for safety, obviously. Be careful here too. You might want to wear some safety glasses here. You don't want that wire. You have those exposed conductors with the pointy ends. We don't want them poking you in the eye. It hasn't happened to me, but I know somebody that has happened to. So if you're going to decide to do this, use caution and use safety glasses to prevent those conductors from poking you in the eye. All right, so I ran into a little issue where the rest of these grounds and neutrals are not going to reach the bus bar for the neutrals and grounds that came with the panel. Because I had to put the disconnect at the bottom, because of the length of my service entrance conductors, I'm going to add a ground bar to the enclosure. And as you'll see, I got 2 of them. It's made by Square D for QO or the Homeline line of panels. And so what I'm going to do is I'm going to add this to the enclosure, and then I'm going to run a jumper from the original neutral bar to this bar when I install it, so that it's going to properly carry that neutral current back to the source for all the circuits that are connected to it. Section 200 Tac 2B, the continuity of a grounded conductor shall not depend on the connection to a metallic enclosure, raceway, or cable armor. This is important because the neutral is a current carrying conductor. And it's really easy because these holes come pre-made inside the bus bar here, okay? And the holes inside the panel are here as well. So as you can see, the hole is already made there for me. It's threaded. Okay. Once they get this in there, it'll be engaged with the 2 screws, and I'll put that section up on the video so you can find out where that section in the code is. I'll have to find it right now. I think it's in Article 200. There's one that's in. There's another. And then, like I said, what I'm going to do is run a jumper. I'm going to add some lugs. I'm going to run a piece of number 4. I should have that in my truck, I hope. So the article I'm going to post is definitely an article, is in chapter 2. But basically what it says, and I failed an inspection for one time because I did not notice at the time. But because we bond our neutrals and our grounds in this panel, everything in this panel is at the same potential, okay? The thing is, the neutral is a current carrying conductor, and the part of this bus, because it's attached to the enclosure right now, we can't use the enclosure as a path for the neutral current in the circuits. What this is going to do, we're going to hook up a bunch of neutrals over here and grounds, and the grounds can be doubled up, which we're probably going to do, and a lot of these that don't reach the bus down here are also going to be over here. So what we need to do is just have a jumper. I believe it's number 6. I'm going to check. If it's not 6, it's definitely number 2 aluminum or number 4 copper, and we're just going to jump from here down to here and call it a day. And the jumper that we're going to put in is going to go from this lug down to the terminal that came with the panel, the official neutral bar. And the neutral bar, when you put the bonding jumper in and the bonding screw, it bridges the neutral terminal to the enclosure. That's what bonding, grounding, and bonding is all about. We bring all of our grounding and bonding to the main disconnect, which is my main breaker right here, and we insert this main bonding jumper screw only here at the main disconnect. And it's going to serve 2 purposes. One, to clear a ground fault, okay? And then also, if you have a line surge from your utility company or a higher voltage comes in contact with the service drop that comes into your house, okay? Also, when lightning strikes, lightning can induce a voltage onto the line without even touching the line. Just the power surrounding the magnetic field around that lightning strike can induce a voltage on the circuit that's coming into your house, the line that's coming into your house, your service drop. And so we want to make sure that if that lightning wants to get to ground, we're going to give it a ground. We're going to give it a connection to ground through our grounding electrodes, which is the main water pipe here and the 2 ground rods. NEC section 250 TAC 4 will explain that to you, especially A 1 through 5. NEC article 250 TAC 4, the general requirements for grounding and bonding. The following general requirements identify what grounding and bonding of electrical systems are required to accomplish. The prescriptive methods contained in Article 250 shall be followed to comply with the performance requirements of this section. A. Grounded systems. 1. Electrical system grounding. Electrical systems that are grounded to be connected to earth in a manner that will limit the voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and that will stabilize the voltage to earth during a normal operation. 250 TAC 4A2, grounding of electrical equipment. Normally, non-current carrying conductive materials enclosing electrical conductors or equipment or forming part of such equipment shall be connected to earth so as to limit the voltage to ground on these materials. A3, bonding of electrical equipment. Normally, non-current carrying conductive materials enclosing electrical conductors or equipment or forming a part of such equipment shall be connected together and to the electrical supply source in a manner that establishes an effective ground fault current path. A4, bonding of electrically conductive materials and other equipment. Normally, non-current carrying electrically conductive materials that are likely to become energized shall be connected together and to the electrical supply source in a manner that establishes an effective ground fault current path. A5, effective ground fault current path. Electrical equipment and wiring and other electrically conductive material likely to become energized shall be installed in a manner that creates a low impedance circuit facilitating the operation of the overcurrent device or ground detector for high impedance grounded systems. It shall be capable of safely carrying the maximum ground fault current likely to be imposed on it from any point on the wiring system where a ground fault may occur to the electrical supply source. The earth shall not be considered an effective ground fault current path. So what does all that mean? Those are the basic requirements for this panel upgrade that we're doing here. Grounding and bonding is a fundamental part of being an electrician. If you are a young electrician or an electrician with more than 10 years experience and you don't understand this, I suggest that you read that section thoroughly. Okay, so I think my camera went out. What I did there, it just got too hot. So what I did was I added this whole house surge protection device. This is the 80 kiloamp version. This is the joule rating. I'm not exactly sure of this, but this is like the highest rated, best surge protection square DQO offers. I guess you could hook this up to home line as well. And the manufacturer suggests that we connect it to a double pole 30 amp breaker, have these feeders from the surge protection to the circuit breaker as short as possible. So that's why we have the surge here and the breaker there. And then of course we have our grounds and neutrals connected down below over here as well. That's what you missed. Always read the manufacturer specifications. You're going to learn things about the products that you're installing just by doing that. Sure, it takes time and you might have a boss that's up your ass saying just get this work done. So then take the paperwork home with you or read up on it online if you know you're going to be installed later that week. Just have an idea of what you're doing before you do it. With QO, there's a specific place they want you to put the surge protection on the bus bar, and that's closest to the main breaker panel. The other brands, such as Cutler Hammer BR, do not require that they be closest to the main circuit breaker. So I know I've been over this before in the comment section, but if you know why QO requires that breaker to be closest to the main breaker, let me know in the comments. Because with BR, we don't need to do that. So obviously you can see some of these labels were still on the cables from the original installation. So I put them on where they go into the breaker. And then when I go to label the panel, when I go back, I'll know exactly what those circuits are doing. There's only a few circuits that I have to find where they're going here. So it's going to be pretty simple. But that's all part of the job, is labeling the panels as well. That is required by Article 408 somewhere, I think, where they have to identify each of the branch circuits. The older the house, the harder it is to find some old circuits because sometimes they get abandoned and you just don't know where they're going. So there's that. This house isn't that old and most of these circuits are already labeled, so it shouldn't be that difficult of a deal. The biggest problem I have when I do a service upgrade is if when I'm done, I turn the power back on. If the internet's not working, then I can't leave, even if it has nothing to do with me. Here, you can see in the lower left-hand corner there's like an 8-way splitter that has it's connected to 120 volts. So it's like an amplifier for the signal. And when I originally turned everything on, I didn't have the receptacle put in there. And I noticed right away that the Wi-Fi wasn't working. So I took care of that before I left. Always leave the main breaker in the off position, test for voltage, and then stand away as you turn the main circuit breaker on. Turn on the individual circuits one at a time, and you should be in business. Then I always go back and I check each individual branch circuit to make sure it's working just right. So this is part one of this upgrade, and part two will be coming up shortly once I finish it. That'll include the portable generator wiring portion. Guys, thanks for watching the channel, and I'll see you on the next one. Thanks for watching this video. Be sure to subscribe, and we'll see you on the next one.